Correlation and regression. Who else want to try, please? Who else wants to try? Hello?
I will suggest you move on, sir.
No, I want us to get this. Bello, Rahman, can you help us? Just we are all colleagues. I just want us to be, let's get something clear.
Okay. Let me come in. In correlation, you are looking at association.
Okay. Correlation, we are looking at association. Hello? Okay.
We are looking at how do these variables, how do they associate with each other?
Okay.
The other one I talked about relationship, but this time the relationship, how do they associate the co-relationship between the two? Are you getting me?
Okay.
Why regression?
Why regression is
independent
what?
variable? Regression refers to relationship between independent and dependent variable.
And also, correlation refers to relationship between dependent and independent variable. So what distinguishes them?
Yes.
I just want us to get that point. What distinguishes them?
Yeah, I know. It's looking at the like I said before, the co-relationship. Looking at the strength of, are they really correlated? Okay. Yes, when you're talking of correlation, looking at the strength of relationship between the two variables.
Okay, the strength of
whereas the regression talks only relationship. The regression looks at the relationship in a form of equation, but this other one looks at it on a straight line, kind of on a linear kind of linear relationship. I don't know.
The way you are struggling with it, Barrister, the way you are struggling with it is the way all of us, if not all of us, are struggling with it. But let's give Bello a chance to explain this.
Okay.
Rahman, Bello, you raise up your hand. Okay, if it's not, I don't know. I hope it's, I'm not the one denying access. Who else want to talk? Bello is not talking. I don't know.
Hello? Hello?
Yes.
Hello?
Who's in?
I think it's coming from Bello. I've muted him. Okay. Barrister Osita, thank you very much. When we talk about correlation try to measure relationship. It try to measure association between two things. But the fact that two things move in the same direction, the measurement of movement, if they move in the same direction or in the opposite direction, it doesn't mean that there is a causative factor. What do I mean? if Barrister Osita and myself Barrister Osita and myself are walking on the same street and going in the same direction, it does not mean that Barrister Osita and myself are going the same way, or my movement is the one leading Barrister Osita, or Barrister Osita's movement is actually the one leading my own movement. But there is an evidence that our movement is in the same direction. Are we together?
Yeah, we're listening. We're listening. We're with you.
Yes, yes, we are with you, Simon. Doctor.
Correlation.
Yes, yes.
Correlation tried to measure association. These people or these variables, they are moving in the same. Are they moving in the same direction, or they are moving in opposite direction? If I move left, is Barrister Osita moving right? If I move right, is Barrister Osita also moving right? So if actually I'm moving right, and Barrister Osita too is moving right, and almost, the same time or in the same fashion, we can say there is a perfect positive, what's it called, relationship for that correlation.
Oh.
But if I move left, it moves right, almost the same time. We can say there is a perfect negative correlation. But the question is, sorry, some messages are distracting me. The question is my movement causing the movement of Barrister Osita? Or put it the other way, is Barrister Osita movement causing my own movement? That is what will now lead us to regression. Regression wants to establish whether the movement in the dependent variable is actually caused by the movement in the independent variable. Are we together? So association,
Yes.
Association or correlation does not really means causation. It does not have a cause and effect. It does not explain, rather it does not explain a cause and effect thing. It only says there is a direction moving in the same direction or in opposite direction. That's what a correlation measures. But regression wants to measure causation. Is my movement as an independent variable making Barrister Osita to move in that direction? That is what regression wants to explain. So basically, regression is used to explain the relationship. Is this independent variable causing the movement in the dependent variable? And that is why some scholars refer to independent variable as explanatory variable. Independent variable trying to explain the movements in the dependent variable. So if having conducted a correlation analysis, correlation just tend to measure the movement, but you cannot conclude with correlation that this movement has a causative effect on the dependent variable. Regression offers the explanation, gives you the guide that truly the movement in the dependent variable, your DV, is actually caused by X, Y, Z, X1, X2, S3 independent variable. So basically, that is what I can explain as the difference between the two of them. So correlation, you do that first to see, is there an association between these variables? If your sales, goes up during rainy season, correlation can say, oh, in rainy season, we have sales going up. But regression was actually want to see, is the rain the causative factor for your sales to go up in that rainy season? That is what regression tried to do. But everybody can see, you can easily see association, but you need to do further analysis to establish the causative factors. And that is what accounting and finance research try to establish. We have our independent variable and we have the dependent variable and the independent variable on the other side. So we want to use the independent variable to predict or explain the movement in the dependent variable. I think with that, we should have a clearer understanding of what the difference between correlation and regression. Any question on that? Any question?
No. No, but sorry, your last statement, you say you use IVs to explain the DVs. What do you mean by that? So let me get you far.
Okay, IV.
When you talked about causation, yeah.
Okay, that we use. That is exactly what regression tried to do, because your independent variable is what you are trying to use to explain your dependent variable. Because what we are saying is when they are independent, independent variable is the causative factor. That is, the movement in your dependent variable is actually dependent on the independent variables. So when you gather as many as possible independent variables, not all of them will actually explain the movement in your dependent variable. If I ask what determines the value of a firm, for instance, I think for those of us in financial management, what determines the value of a firm? We can give as many variables as possible. One, maybe ROA, ROE, liquidity, firm size, and so many other things, so many other firm characteristics. But what we want to do in accounting research now is to empirically test this variable, that which one has the explanatory power that can tell you that this is what makes the value of a company to go up, or this is what makes the value of a company to go down. And that's why you line up your independent variable to regress them against the dependent variable. The one that is positive and significant simply means that that independent variable has the explanatory power or has a predictive power over the dependent variable. That it has a very, a strong influence on the movement in your dependent variable. Does it, does that explain it? Barrister? Chika, you want to ask a question? Can I continue? Hello, can I continue? Hello?
Yes, sir.
Okay, Governor, your line is breaking. Hello? Dr. Rabiu, can you hear me? Unmute yourself to talk, please. Hello? Hello?
Hello, sir.
Hello?
Now that you unmuted us, we are following, sir.
Okay, I want at least I
Thank
want to
you.
be sure that I'm not disconnected. That's what I'm asking.
No, we're here, but just that you muted us.
This
But
muting,
it's okay now.
but I don't know what to because I don't
You
understand.
muted all of us. So look at the chat. You can see others have been writing to you.
Okay, from the chat,
Look at the chat now. You should be looking at the chat, my prof.
you are still unable to unmute.
No, but
Hey.
we're okay now.
Unmute us, everybody. We are muted.
Okay. Maybe a governor, who can dare to, I want to, somebody should be a co-administrator so that the person can manage that end for me.
Is the governor now? Are we contesting it? Any primaries here?
But you are the assistant now.
Yeah, you should leave it open. You should leave it open, Dr. Simon.
You to prof, governor.
Governor's network seems not to be okay.
Dr. Simon, can you hear me?
Oh, Dr. Rabi.
Network palaver.
Yeah.
Yes. Okay, so that's fine. That's fine.
Shaking.
I can hear you. But it's like as I unmute, I said maybe you're unmuting yourself, it's muting again. Barrister Sita.
Yeah, I'm with you.
Okay.
I'm with you, sir.
Okay. Let others unmute themselves if they want to talk, because I try to unmute and it's locking up again. I don't understand. Barrister, let me make you a co-host, Abby. But those want somebody to just. I said I'm making you the host. Oh, but that leaves me. Okay. Oh, will I be able to share my screen? Okay, let's continue.
We're handling it now. Let's see how it goes.
Reclaim host, mute me, invite. Is this muting of a thing? I don't understand. I've tried to unmute everybody. Okay. So back to what we were saying. Basically, that is what regression and correlation do. So I want us to move into a practical session. I want to share share my starter screen, and we'll see how we can conduct this the descriptive, that's the summary statistics, correlation, and conduct a simple regression, that's a multiple regression analysis, and possibly do what's it called, logistic regression, or I mean, that's binary regression. Is that okay? Yeah, let me come back. Can we see my screen? Barrister Sita, I needed you to give me feedback. Can we see my screen? Hello? Barrister Sita, can you see my screen? Barrister Sita.
Yeah, I'm muting. I'm fine now.
The thing automatically mute. So that's my problem. It's not that I don't intentionally, I'm not doing it. So I want to be getting feedback to know that you can hear me. Okay, can you see my screen, Barrister?
Yes. Yes.
But if others, please, if you want to ask questions,
yes,
please, just unmute yourself and ask the question. This is a typical what's it called, starters environment. Starter, like we all know, is a statistical analytical tool, basically designed for social economics and social sciences. And that is what, at least, is one of the popular statistical analysis tool. And I think it's best for us to at least get to know how to use it. Even when you are not going to do your statistical analysis yourself, you know the relevant question to ask. Are we together? So the starter environment is what we can see now. Normally, like most what's it called, softwares, you have the menu bar. You have the menu, just like any other, let's say like Excel, for instance. But here, now, can you see the highlight when you have these results, highlighted regression results? Barrister, can you see that?
Yes, I'm following.
Okay. Yes, still muted. Can I just can I just just give me a minute or two? Let me try and resolve this muting problem, so that you can have
Take 5. Take 5.
5. Okay, please.
Take 5.
Sorry about this. Let me just see how I take control of this muting issue.
Yeah. Thank you.
Yeah. Okay, try and unmute yourself now. I think you should have the power to do that.
Yes, it is done, sir.
Okay. Oh, so sorry about this.
Yes, it's better now.
Okay. So
Well done. Thank you.
sorry. So we have been able to resolve that. So if you are not talking, you can mute. Yes, Governor.
Sorry.
Dr. Simon, make
Governor.
make Barrister Osita a co-host so that he can control the class.
Okay. Okay.
Why? When you are there?
No, I'm busy.
I'm only a deputy. When you're not available.
She's the one that's delegating you now.
I'm not available now. That's why I'm asking that you are seated there. Your full attention is there.
She has to take care of the other
standing.
room.
You say I'm seated. I'm standing.
Yes, so it's our room.
Okay, I'm not able to get the feature for co-hosting. Maybe we should just continue. What I did before.
I think we can continue. At least now that we can unmute, it's better.
It's better. Okay. So we are in the starter environment. I'm sure some of you have a starter in your system, and I try to I shared a kind of a class work.
Yeah.
The person should mute himself. Oh.
Okay, sorry.
Click on Barrister Osita's name. Just click on it. It will give you options.
Okay, to make him a co-host, Abi.
Yes, sir.
But make host. It just making host, and it will transfer. It transfers it to him. Okay, no problem. Do you want to change the host to?
No, co-host is there.
I'm not saying co-host, but I can transfer it to him. Let him manage that. Make host
Okay.
name, and that's it. Okay. Do you want to change the host to Osita? Yes. Okay. So, but you will give me the rights to. Now, I'm disabled from sharing.
Okay, return back now to be a host. But for when you click it, the co-host function will come out. You will now make the person.
Are you sure that is not a premium service?
Yep, sir.
Barrister Osita, reclaim hosts. Okay.
Somebody who is not available.
Continue now, but let everybody on mute so that there won't be noise at the background.
Yeah. Okay. Okay. So I was trying to share the starter environment. Can we see my screen?
Yes, sir. You can see.
Okay. So those are some of the regression that we have run earlier. So where I'm scrolling is where where you run the regression, where you run the regression. So I want to also, I shared a kind of a class practice, the practice question at the class. For this session. Where I was trying to use a football club. I don't know, so you read through it?
Manchester and Liverpool now is there.
Yes, Manchester and Liverpool. Okay. Now I want to go to that of Liverpool, and let me show you what I'm trying to do with that regression. I deliberately left academic environments. Let's let's look at things from maybe another perspective of life. In football, what determines the success of a match? You will see the statistics that if you are Governor and Talbot, pardon me if you don't understand football statistics, but I'm sure majority of the men do. I'm still going to bring examples that can be universal.
Okay.
So please just follow. In a football match,
they know.
You only see the statistics. Ball possession, number of passes. What other thing do we see? Let's talk.
Group formation, team formation.
Team formation. What other statistics do we see?
Shots on target.
Shot on target. Number of passes completed. Am I right?
Yes, corner kicks.
Corner kicks, that's the offside, the number of red card or whatever. Do you agree that these are variables? Do we agree that these are variables? And are they independent variables?
Come
Hello.
again. Come again.
I said in football matches, we have statistics.
Mhm.
We have ball possession. Is that correct? We have number of passes completed, shot on target, and number, apart from shot on target, you have the other one, maybe just number of shots. Am I correct?
Mhm.
Corner kicks. What else? You have the number of maybe fouls, red card and yellow card.
Yeah.
If we take all this as independent variable, it means that we can regress this variable against the outcome of a match, being a team winning a match. The outcome of a match, if ball possession is what's it called, 90-10 for Man City versus which club is that? Man City versus
Liverpool, yeah.
Chelsea. No, they're not get strength. Liverpool versus Chelsea. If ball possession, if ball possession is 90.
Yeah, so these are our answers. Some of them are actually very, very interesting.
Are we together?
That one.
Okay, I was saying, if ball possession in favor of Man City is 90%, number of passes is like 600 to 200 for 200 to Chelsea. Shot on target is like maybe 13 for Man City. For Chelsea is like maybe 4. Shot on target maybe like 4, and for Chelsea is like 1. Number of corner kick maybe 5 for Man City. And 2 for Chelsea. Number of fouls maybe 2 for Man City and 6 for Chelsea. From that statistics, as a football fan, who is likely to win the match? Hello? Did we follow?
Man U, now the person that has the
Man
number
City.
of ball position and
that's the ball possession, attempt at goals, shot on target. They have lower number of fouls and have higher number of corner kicks. What I'm trying to say is these are independent variables that can explain or predict the outcome of a match. True or false?
It's
Do we
true.
agree that it's true?
Yes, true.
Yes.
True.
So that is exactly that is exactly what we try to do when we run regression analysis. We can use it to predict or explain why Man City is going to win the match.
Hello?
We can use these statistics to explain why Man City is going to win the match. Or we can use it to predict why Man City will win the match. So I said independent variable are explanatory variable. They are predictive variable. You use them to predict the outcome. Outcome of the match is the dependent variable. Are we together? Are we together?
Yes, sir.
Okay, so let's go back to the starters environment. I want to try and bring in some data for us to use to run the regression. Can we see my screen? I'm on the what's the data menu, and I'm going to data editor. I hope my data edit, you'll be able to see it. Can we see my screen? Are we seeing my screen?
Yes, sir. We can see. We can see.
What are you seeing? Are you seeing the spreadsheet?
Yes, sir.
Okay. I'm trying to import data for this analysis. And that was why I went from, what's it called? From the data menu. Data editor. And I clicked on the data editor to get to this point. I have the data copied. The data I'm using is from, I shared it on the WhatsApp group. If you have your if you have your starter, you can maybe run it alongside. So it's asking, do you want to treat the first row as as variable name or data is a variable name? So I'll bring in the result I want us to, just to run this simple regression. So very simple regression. That's the Liverpool. Okay, let me change. The Liverpool let us be on the same page. Yeah, okay. This is the Liverpool statistics I want to use to run this regression now. Maybe if the dependent variable match results is measured as 0 for loss, 1 for draw, 3 for win. The independent variable here are ball possession, and goals attempt. Are we together?
Yes, sir. We are following, sir.
Okay, I'm just using.
Yes.
I'm just using two what independent variable. Are we together? Two independent variables.
Yes, sir.
So which are the two independent variable now?
A ball possession and a goals attempt.
Ball possession and goals attempt.
Yes,
fine.
Sir.
Yes.
So and the dependent variable is the result.
Yes, sir.
Dependent variable is the result. So I've imported this information into our starter. So let's go back to our starter screen. Now, can you see my starter screen? Are we together?
Yes, sir. Yes, sir. We're
Yes.
moving.
Okay, you can see 3 variables and 20 observation. Is that correct? Can you see that?
Yes,
Yes.
sir.
Those are the information I imported from the Word document. I copy and pasted into the starter. So the first thing we need to do is to get the summary statistics, or what we call the descriptive statistics. So the beauty about a starter, like Dr. Henry passes all through the menu method. If you have attended Henry's class, it passes. It makes you go through the menu to be able to run your statistics. Are you with me? But I want us to start using command. To start is very simple. Using command to start navigating. If you know what you are doing, command for me is simpler and faster. So for this data that we have imported, if I want the summary statistics, it's a matter of typing sum. Like if I put sum, enter. Can we see the descriptive statistics?
Yes.
Or you can also, instead, if you want to go the long method, if you put summary, it will still go. Sorry. Summary. Or summarize, rather. Sorry, I think it's summarize. But I'm used to the short form.
Sorry, we didn't get before that place, so my internet is unstable. Hello?
Hello? Okay. You followed us up to the point of when I was saying that there are 3 variables which I highlighted that have been imported.
Hello?
Hello, Barrister. Can you hear us? Barrister Sita is not hearing. Can I continue?
Yes, you can continue.
So this is the descriptive statistics. By simply typing sum, enter, you get your descriptive statistics. Now you can see that the results, ball possession, goals attempt, they have all been imported. What can we explain from this descriptive statistics? There are if you are writing a research paper now, I can easily say from the descriptive statistics above. Okay, Governor. Governor, go ahead. Your network is really dragging.
No, my question is before using the, okay, can you hear me now?
Yeah, go ahead.
Can you hear me?
Go ahead.
Oh.
Are you hearing me?
Before using the command,
Yes.
you still okay. Before using the command of sum and enter, do you see I can hear you very well, sir. I said before using the command to bring out the descriptive statistics, you must have on the starter, would you have chosen descriptive analysis?
Okay, if I'm getting you, that it's on the starter before running the descriptive statistics with the sum command, whether you will have selected the variables.
What I mean, you use that command when you are already in the descriptive statistics environment.
No, I'm not passing.
Must have entered all the variables, the dependent and independent variables imported from your Excel or from where?
Okay,
at that point you use
having imported the data into this into starter through the data editor. The next thing is for me to do is just if I type in the sum, I don't have to go through the menu. I don't have to go through the menu to start selecting. For in as much all the variables that I needed are already is what I imported. It's only when I want to choose, maybe I had about 10 variables. I want to choose maybe 5 out of the variable to run summary statistics. That's when perhaps I will need to go through the what's it called? The variable panel. There's a panel here. Can you see? I've highlighted it. Can you see that?
Yes.
So if, for instance, I'm back to the command menu. I'm back to the command. If I just want to run, I want to regress ball possession against results. I can say sum space, then double click on ball possession only. Sorry, regression first. The DV first. That's the dependent variable must come first in that order. Result is the dependent variable. The next one will be what's it called?
Ball possession.
Ball possession. I just want to run it against ball possession. Once I do sum result ball possession, enter. You can see it's only the 2. But since I'm running it against all the variable, it's even summary statistics. So if I do sum, only sum, it brings all of them out. But if I want to be selective, that's when I go through this other route of just typing sum space and you click the variable of interest, maybe results and goes attempt now.
Okay.
You understand? So if you want everything together, just simple type in sum. You have it. So I was trying to say, if we were to run to write your descriptive statistics session now, it's as simple as saying that a total number of 20 observation or samples were collected for the three variables. Am I right? For the 3 variables. For results, the mean score is 2.65. Standard deviation is 0.075, while the minimum value for the result is 0 and maximum is 3. So I move on to if I want to describe the ball possession, the same thing goes for ball possession with the same number of observation. The mean score was 64.125 and standard deviation, and so on. You have completed your descriptive statistics. So after descriptive statistics, what next? What's the next line of analysis? Correlation, am I correct? Am I correct? Hello? Feedback. Okay, the next thing is correlation.
Yes, you're correct. You're correct. Correlation, no?
So
yes, sir, you are correct, sir.
Okay, if you want to run correlation, as you know, you can probably go through the menu. How do you go? Statistics, Am I right? Where do you go through? From menu. I don't do menu method.
How do you do it?
Simple. We are back to the command. To the command. Kuro. Can you see what I have done? I mean, what I typed?
No.
Call.
What is it?
Call. Can you see it?
Yes, correlation.
Okay, now. Yes.
Call.
Yeah.
Enter. So that is for correlation. It's as simple as that. But I mean, with this, you have done your correlation.
Excuse me, just type call, then enter.
Yes.
Okay.
You can try it again. Just watch my typing.
If you enter it full, uncle.
Coro spelling.
Prof.
No, correlation is sorry. Is it double R? Yeah. Double R.
It's correlation.
Correlation.
If we write correlation in full, will it still give the same result?
You can see the error message.
It says not recognized.
Good.
Okay.
As you are continuing, I'm not sure. I mean, the command for correlation might just be maybe correlate, not correlation. Where is that? Let's take it again. Let's put it as correlate. I think it's in verb form, action word, verb form.
Okay, you're right.
Is the verb form will work. The noun form, the noun form will not work. Just like the way I did when I did summary, it didn't take it. But when you say summarize, it's a verb form. It works.
Yes, because it's a command.
It's a command, so it has to be action based.
Yes.
Okay, so that is how to run. I mean, that's the correlation. Can somebody offer to explain this correlation?
Wait on, sir. Can I go ahead, sir?
Please go ahead, Babatunde.
Thank you, sir. What we are correlating is between the dependent variable, which is a result, and the independent variable, goal projections, and a goals attempt.
Yes.
So if you look at the on the row side, you know, we have a result, we have ball possession, and we have a goals attempt. While on the column side, we have result. So if you look at the result and result, there's a perfect.
There's perfect correlation, which is 1. Go ahead, Babatunde.
Correlations, which is 1.
Yes.
Can I go ahead? Oh God. Hello, sir.
Yeah, go ahead. Go ahead.
So the relationship. So there's a positive relationship between ball possessions and the result, and it's about 68% relationship.
Okay.
Between the ball possessions and the result.
Okay.
While between the goals attempt and the result is about 56%.
Yes.
So if you now look at the relationship between the ball possessions and goals attempt is about 92%.
92%. Yes.
Yes.
That's a
Goals attempt
goals
and the
attempt
ball
and
possession.
ball possession. What does
Yeah,
that
it is.
explain?
So it means that there are positive relation between the two.
They are positive. Is almost getting to a near perfect,
Perfect. Yes.
perfect relationship.
Positive relationship. Yes, sir. Yes, sir.
So when you see 1-1-1, it's related to me for there to be that 100%, that 100% perfect relationship is the same variable against the same variable.
Yes, sir.
Ball possession against ball possession is 1. Result against result is 1. Goals attempt against goals attempt is 1. So ball possession to result shows 68%, like Babatunde has said. So it's positive, but not a perfect one. Highly positive, but not perfect. And
sir, can we say that it's not perfect but significant?
No. Let me also,
Okay,
I wanted to correct you when you were explaining.
Okay.
When you are doing correlation, never you use the word independent, dependent variable, because correlation is not measuring dependency.
Okay.
Correlation does not measure dependency.
Okay. Yes, sir.
What measures dependency is regression.
Okay.
You understand?
Yes, sir.
So there is a perfect relationship or a near perfect relationship between result and ball possession.
Okay, sir.
There is positive. You can use the positive or negative relationship. But in this case, in the case of this data we have, they are all positive relationships. And mind you, your regression results varies between -1 and +1. Hello?
Hello, sir. Yes, we can hear you, sir.
Okay. I said your correlation results can never be greater than 1. And it can never be greater than -1. Is that taken? Your correlation result over between -1 and +1. Is that clear? Are we together?
Yes, sir.
So correlation ranges between -1 and +1. That should be noted. So whatever interpretation somebody run regression or gives you a correlation table, and you are seeing 1.5, know that is a forged result. Nothing like that. You cannot. Your correlation is within the band of -1 and +1. Nothing more than that. So with that, we have an idea of how to run a correlation. Am I correct? Am I correct?
Yes, sir. Yes, sir.
So for correlation, like I said, and let me say it again, there's nothing like, you are not looking at dependent or independent variable. These are variables. You are just trying to establish association between them. And it's a, what's it called, pairwise. You take it pair by pair to interpret. Result against result against a ball possession, result against goals attempt. If you move to the next one, it will now be ball possession against ball possession against goals attempt. And that is it. So the next thing we'll do is we'll move to the, what's it called? Regression analysis. But pardon me, 1 minute, I need to ease myself. Thank you. I'll be back now. Okay. Hello. Hello.
Well, yeah.
Okay. So we'll do regression now with the data we have.
Sir. Welcome back, sir.
Thank you. We'll just do the linear regression. Godwinian, okay, sorry. Somebody is in. So we're going for linear regression. So for the regression.
No, I thought you said regression analysis. That's where you left.
Regression analysis, that's what we're doing. I'm just saying, yeah. I'm being specific now. Linear regression, not binary regression, not logistic regression. I'm just being, they are all family of regression.
Okay.
They are family of regression. Oh, sorry. Let me just pause a call.
Oh, network.
Hello? 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 So can I call? I'm in a Zoom meeting. I'll call you back. Yeah, please don't let me come back. Sorry. Thank you. Yeah. Yeah. Hello? Okay, Barrister Sister Osita, is that clear now?
No, I didn't get you, sir.
I said it's regression we are doing. I'm just being specific on the type of regression we are doing, which is a linear regression. You know, you have linear regression,
okay.
And you have binary regression. So I'm being specific, another type of regression. What we are doing now is linear, linear regression.
Binary, all those stuff, yeah.
Yeah. So to do a linear regression is simple on starter. Again, I'm not going through the menu method. I'm just going through the command method. So regress. Are you seeing what I type under the command? Regress space. I will go to the variable to pick my variable bar, window. You can see the variable bar window is, that's where I am now. I want to pick my DV for this regression is a result, right? Can we see it? I will double click on the result and it will come down. Have you seen can you see it?
Yes.
Okay. So regress results against space. Against what? Ball possession. I will double click ball possession. It comes down to the command window. And I will regress it. Another space. Regress it against goals attempt. Double click.
Goal attempt.
You can see all the variables of interest now. I want what the command is saying now is I want starter to regress the independent variable against the dependent. The dependent variable is results. Independent variable are ball possession and goals attempt. Having set the command that way, enter. Why do I have this? So, regress, okay. We are regressing a ball possession. You can see the command here. You can see my highlights. Can you see the highlight I made?
We can see.
Yes.
Okay. If I go, you just Control-C, copy, like I want to do it again. And I say paste. I think it should just, it will run the same thing over. Is that clear? That's Control copy. That's Control-C. Go to the command and paste. Enter. So that is our regression results. Who will volunteer to to analyze this result for us? First, I want somebody to explain what we meant. The R square, the basic statistics. That's one of the things that we need to know. What does R square stand for? What's the R square there is 0.50. What does it stand for?
I seems to be lost.
Please, where are you? Where was your last point? Pastor Friday, are you the one?
Yes, I'm the one that said I seems to be lost because I was not pulling on my internet was unstable, but I think I'm getting it now. So I couldn't follow up.
Okay, but you were there when we did the correlation?
I was not there, but I was there when you were asking us to define correlation and regression to find out the difference.
Oh, we have gone far then. You must have, that's a while. But basically what we have done, after defining and distinguishing between correlation and regression, we started running the basic, the three statistics. That's the summary statistic, which is also called.
Can we go over it again, sir?
That is exactly what I'm doing. I'm just trying to give you a background. We did the descriptive statistics.
Dr. Simon. Dr. Simon, yes. Can we go over it again?
Okay.
Yeah.
That's what I'm doing. That's what I'm doing. I'll do that. First, we have run the descriptive.
Okay, thank you.
Second, we have done the correlation. And third, we have done the regression. Now I will go to the descriptive statistics again. Like I said, my approach, or what I use, is the command approach. Using command, starter command, to get what you want. The other method that, what's it called? Henry taught us is going through the menu the menu method, but I think the command system, I'm very much at home, comfortable with that than looking for maybe a manual that will be going through, do this, go to this, go to that. If I have a command, it will take me directly to where I'm going. You understand? So that's why I say, okay, let me share this with us. So for the descriptive statistics, the command we use is just sum, SUM, which is the short form for summarize. If you don't want to go, you don't need to type it in full. If I say summarize, is a command. I'm asking Stata to actually summarize the attributes of the variables that I've uploaded into Stata. So once I type summarize, I click enter. You have the summary statistics. Is that clear? If you don't want to type it in full, you can just click, use the words summary. Sum, enter. It will still give you the same result.
No, summarize.
It's either you can use sum,
Summarize.
you can use sum or summarize. Once Stata is so friendly, even if you say sum, SU, if I say sum, SUM, it gives me the same thing. If I say sum, MM, it's still giving me the same thing. If I say sum, RI, maybe it's not complete. It knows the direction of the words. It's still getting me the same results. So the one I have not tried single S because other commands might actually start with that. So there will be a conflict. So, but if I say SU, it takes it. Let's try whether it will take S alone. There's a problem with that because other commands might start with S. So Stata will not know which command you are looking for. But once you say SUM, you are moving in the direction of summarize, it brings out the result. So, Rahman, is that okay?
Yes. Yeah. Thank you so much.
Okay.
I'm flowing now.
Okay. So, and we know how to, we'll explain how to, like you are described in your chapter 4. You will be described, at least you write some narrative of the descriptive statistics. Whatever you are going to do, all the information are here. And we said, okay, we had 20 observation, and there are 3 variables. 20 observations and 3 variables. For results, the mean value is 2.5 and 2.65. Standard deviation, which is a measure of a dispersion, is 0.875. The minimum value for result is 0, and the highest value is 3. So I've described the results. We can describe the ball possession that same way, and same goes for what's it called? Goals attempt. So that gives us an idea of how to run descriptive statistics using the command approach. Again, let me state that. Let me state this. To my left, you see the history window. I've highlighted the blue color now. Can you see it? Are we there?
Yeah.
You can see it now. So it's giving you, what you are seeing on this history window is all the steps, all the commands that have successfully and unsuccessfully executed. The ones that are successful, they are in black. The unsuccessful one is in red. Huh? Are you getting it? So, but what is the benefit of having the
Yes.
What's the benefit of having the history? If there is a command I want to repeat quickly, I can just go to it. Are you like number 75? Can you see it? 75. What's there? Regress, results. Huh?
Ball position.
So as I click on it, enter. What I've just done is to repeat and asking that command. I just brought it out from history. Just execute it again.
Hello?
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 Hi. Rahman. Any issue? Rahman, can I continue?
Yeah, your line was breaking, so I lost some points there.
Okay. I said on my left, you have the history window, which I screw. Can you see it now? These are some commands that I've run in recent time, showing in the history. Showing in the history. So if I quickly want to, without typing, I want to rerun the same command, like the regression command. I can just double click and it will run it for me immediately. I don't know whether you noticed that. It has run a regression now.
Yes.
Okay, but let's not jump over correlation because of Pastor Friday. Pastor Friday, are you there? We have done.
Yes.
We have done the summary statistics now. Hope you are flowing.
I'm with you, sir.
Okay, so we'll move to correlation. We want to run the correlation the same way we ran the summary statistics. To run correlation is also as simple as ABC. Just type the word C0 R. If you stop at R, it will still take it. Maybe C0 R. That is correlation. Let me repeat that. Correlation. Let me write in full now. Correlate, like I said, is the action verb. Is the action word, which is a verb that starter takes as command. It has its registered command, but they are in verb form. If I say correlate, enter, it will still take it. So this is correlation results, and we try to interpret correlation results as when you see 1, it shows that is a perfect relationship, and is result against result that can give you perfect relationship. Ball possession against ball possession will give you perfect relationship. Goals attempt against goals attempt will give you perfect relationship. And we said for correlation, the value ranges between -1 and +1. The value of any correlation must be within that range. -1, +1. Anything above that is a forged result. It's not valid. So that is it for correlation. Any question? Can I move to regression? And let me also see, like Babatunde asked the other time, when you are explaining correlation, it's a relationship. It does not explain anything dependent or independent. It's just trying to see association between the two variables. is blind to which one is independent and which one is independent. So let's note that, so that when you are describing, you don't go and be using the word positive and significant, because you are not testing. It's not inferential statistics. You are not trying to make an inference from that. You are only trying to establish an association, a relationship. Is that okay? Now we'll go to correlation. Pastor Friday, we are moving to correlation. Any question? Sorry, we're moving to regression.
No, sir.
Okay. Now, regression is an inferential statistics. Inferential meaning that we want to draw an inference. We want to draw a conclusion. We want to make a prediction, or want to make an explanation. That is what inferential statistics try to do. So, for you to run a regression, you must identify what is your dependent variable and what is your independent variable. Your independent variable is also, in fact, some scholars prefer to call it explanatory variables. They prefer to call it explanatory variables, because sometimes, as you will see in the, maybe in the future, when you say something is independent, they should not affect each other. True or false? Hello?
True.
So if something is independent, they shouldn't affect each other. But as you advance in the statistical analysis, you will discover that the issue of multicollinearity do occur. So that's perhaps explain where some prefer to call independent variable as explanatory or predictive variable. They explain their influence on the dependent variable. They predict their influence on the dependent variable. So with that background, let's just quickly run our regression. We are still using command to run regression. And like I said, since you want to regress independent variable against the dependent variable, we need to identify our DV. What is our dependent variable in this example? It is the, what's it called? The results. What we call results. Is our dependent variable. That's this. Check the variable section. That's the upper right column. Upper right window. Can you see result there? We have result, we have ball possession, and we have goals attempt. So this we want to regress the independent variable against the dependent now. So the starter command is just simple reg, meaning short form of regress. I can type it in full, regress, because that is verb, action word, space, type in. Let me also state that starter is case sensitive. Hello? Starter command is case sensitive. If you go and put capital letter in your variable and it's actually in starter as is single, what's it called, small letter, starter will not recognize that word. Starter is case sensitive. So I would rather prefer to, that's why I prefer double clicking on the variable from the, what's it called, from the variable window. The first that we'll pick is, what's it called, result, which is the the DV, that's the dependent variable. You must put your dependent variable first. So I double click on it so that it can go to the command side. Double click. You have it on the command now. Okay? What I'm saying now is regress results against what's it called? The independent variable, which is ball possession. I double click there again. You have it down. Ball possession has come down. The next one is goals attempt. I double click, it comes down to. So all the variables are there now. The next thing is just to hit enter and you have the results. So running command, running regression command is as simple as that. Are we all together? Are we all together?
Yes, sir. Yes, we are together.
Okay, somebody can explain to us what we make. What's the R square all about? R square from the result. Let me highlight it. We can see that R square is what? Is 0.50.
Go ahead, sir.
Rama, you want to explain?
Babatunde, sir.
Okay, Babatunde, you have the floor.
Yeah, okay, thank you, sir. The way I understand the R square, looking at the data, both the dependent and independent variables, result being a dependent and ball possessions and the goals attempt being an independent variables. This R square is trying to explain that there are many other variables that can influence the result of a game that is not covered by this particular data. Having two independent variables only explain 50% of the entire variables that can explain or that can give a result.
Exactly. I think Babatunde has hit the nail on the head. The R square is telling us that this independent variable that we have for this analysis is only able to explain 50% of the variation in the value of the dependent variable. 50%. Whatever analysis we are doing now, that this ball possession and goals attempt only explain 50% of what will give you results. So that means he's saying that there are other possible variables that will determine the result of a match. Is that okay?
Yes.
So I think that is a key statistics we normally see in paper. If you see any paper, you always see that the R square is always emphasized. So in a situation where your R square is just like maybe 5%, what's the implication for your paper or for your research?
What percentage, sir?
Who is talking? Rama?
If the R square is what?
No, not me.
Okay. Okay, my question is, if the R square is just like 0.05, what is the implication for the paper you are writing?
The way it may be rejected. No need to further that study anymore.
Did we hear him?
Yes.
He's saying that the paper.
Wait, no.
He's saying that the paper will be rejected because 5% is only explaining
it's very small.
Very small, only explaining 5% of factors that affect the independent, the dependent variable. So your variable, they don't really have significant explanatory power. They don't have that explanatory power on the dependent variable. That is why the R square is always very important. If your R square is becoming very low, it becomes issue of a concern. But I've seen so far in my little experience, I've seen papers of 30% being published, even 20% being published. But I don't think I've seen anything in the range of 5% or 7%, 8%, 10%. I have not seen. So once your R square is not having explanatory power, your variables, you are saying that this variable you have selected, they no carry weight. Let me use our local parlance. They no carry weight. You understand? So once you run a regression, you must put your eye on your R square. You must put your eye on your R square. Because if it's too low, then perhaps you need to add in more variables. Look for more variables that can explain the relationship. So that is
okay. Hello.
Yes.
In this case now, this one that says 0.5021, which means we have to reject it.
No, this is 50%.
No, it's 50%.
This is 50%.
Okay, 50%. Okay.
Yes. This is very good.
Okay.
50% is good. The one we are talking of is 5%. That is 0.05.
I see.
So at 50% is good, 30% is good. Yeah. Barrister, and all yours.
Okay, sir. What of the adjusted R squared?
Barrister Osita, I'm not the professor of statistics. So.
You know, prepare before you come.
Are you testing the lecturer?
They are appearing before. Listen, they are appearing before PhD in view. PhD in view candidate. So it's very well prepared.
Allow you to take us step by step.
Barrister, I'm not a Chananiga, no.
That's what I'm suspecting, you know. And I want to use a Benish M score to scatter the whole thing.
But in fairness to Barrister, I think the question he asks is very apt. If you have more insight, please.
Yes, I think my understanding of it is basic. That the first R square is what papers focus on. Adjusted R square is just maybe making adjustment for error in the computation. Adjusts it further to 44%. But normally, with my limited research knowledge or papers that I've been going through, the difference between the R square and the adjusted R square, they don't differ too much. You can't see R square of 50 and you now go and see the adjusted R square at 10%. It's not likely. It's not likely. So it's more like the adjusted R square is another robust version of the R square, but it's still the same thing they are measuring, but it's an adjustment for error. Is that okay?
Thank you.
Excuse me.
Yes.
Please, can you explain that number one again? F217.
F217.
What does that mean? What does it stand for?
That is F statistics. I think it measures the probability. It's a probability measurement. It's a measure of probability. That's a little I can, but that is what is called the F statistics. And
Okay.
because it's less than, they don't explain. I mean, in papers where I didn't bother myself much about it. In papers that I've read, they don't really give explanation into, trying to explain what the F statistics is about. But it's a measure of, it's a measure of a probability. And
okay. Which of these statistics do we pay attention to that we must understand very well? Apart from R squared.
The next one. I'm trying to come back to my screen. Okay, the next one is if you take your R square, the next one you should pay attention to is your coefficient. So the coefficients.
Okay.
The coefficient, and after that is the p-value. The p-value. Now let's explain the coefficients. Or should we explain the p-value first?
No, coefficient first.
Coefficients. What coefficient does is this. Because, like I said, the independent variable is offering explanation.
Even as I'm talking to you, I'm not zooming.
Osita, mute yourself.
Okay, sorry. I'm sorry, gentlemen.
Barrister Sister is Anam na Zoom meeting. Okay. Now we have, like I said, coefficient is what we want to explain. That is another key value that you must get to understand. And I was saying that independent variables have predictive or explanatory value regarding the dependent variable. So the coefficient is simply telling us that, like for ball possession, the coefficient for ball possession is what? Is 0.505.
Yes.
50%.
So for what that means is for each movement in ball possession, if ball possession should increase by 1 unit, if ball possession should increase by 1 unit, result will increase by 0.5 units. Okay. Can I take that again? If ball possession increases by 1 unit, it increases results by 0.5.
Where do you get the 0.5?
That's the value, the coefficient value of
that is 50%.
This is, are you seeing my highlights?
50%.
Are you seeing my highlights?
Yes, I've seen
yes.
That's the coefficient of ball possession. What is the coefficient for goals attempts?
Minus
0.166.
Minus, that's 0, minus is 0.166. And this is where sometimes statistics could be nonsensical.
Take that again, please.
I say sometimes statistics could be nonsensical. Sometimes, I'm not saying just a rare occasion. because the interpretation or based on, yes, maybe my data might be wrong, because I picked actually picked all these statistics online, maybe before running the regression. But what I'm trying to say, if goals attempts, what this is telling us, for each unit increase in goals attempt, it will have an adverse, it will have a negative impact on results. Does that make sense? Realistically, in the real world, I think in the real world, when your goals attempt is increasing, your chances of winning the match increases.
Yes, that's how it's supposed to be.
But for this statistics, is showing otherwise, that the more goals attempt you have, the less
chances
of winning the match or having a positive result. Perhaps in some sense it makes sense. Maybe you do not have the conversion.
It's true.
You do not have the conversion capability as a team. Your finishing is getting poor, and that's why you are having more goals attempts. You are not able to convert your goals attempt into shot on target. Let me put it that way. If it's shot on target that is behaving like this, one will cause, it calls for worry. I think that's a better explanation. But since this is goals attempt, not goals on target, that means you do not have, your finishing power is weak on that goals attempt. The more goals attempts you're having, it's not translating into goals. So maybe a more precise measure would have been maybe incorporating goals on target. So for a coach to improve on the team, and just like, this is like a diagnosis now. If we were to be what's it called, Pep Guardiola, maybe I need to start training my team to increase the accuracy of their shot from goals attempt to increasing goals on target. So, like, if this is the recommendation, if this is a paper and I'm making recommendation, I will be recommending that based on these statistics, Pep Guardiola, the manager, should ensure that the team focus more on increasing their shot on target, rather than looking at goals attempt. Goals attempt is a wider score. It's a wide score. Be more precise. Let your goals be go for more precision in your goals, not just attempting goals. Don't make a shot until you are sure of hitting the net, or you are actually facing the net. Hope I'm not standing like a technical advisor to football team. Are we together?
Yeah.
Yes.
Okay. But what I'm saying doesn't make...
It's understood now, because
yeah. Okay. So
it makes a sense. Sorry.
Are
you hearing me?
Yes.
It makes a lot of sense.
Thank you, sir.
I remember in the wildest world, when we were young, they say 4 corners make 1 goal, which never materialized. In the case before, 4 corners make 1 goal. Are you with me?
Yes, yes.
It never materialized. It never. So goal attempts will never give you goals. They're only attempts.
They're attempts.
They're attempts. So I think the scientific, the statistical result is in order.
Okay.
Is in order. Instead, ball possession has 50% chance or chances of your scoring a goal.
Yes, that's what it
than
means.
goal attempt. That's what
Yes.
it means. It's sound. It's a sound result.
So the next thing, these are the coefficients. So, but for us to hold strongly to this interpretation that we have given to ball possession and goals attempts, we need to rely on the p-value. The p-value. So the p-value for ball possession now is 0.02. So if your p-value is less than 5%, it means your result is significant at 5% level. If it's less than or equals to 1%, that is 0.01. It means your result is significant at 1%. That means we are saying that I'm 99% sure that this variable explains this. So in the case of ball possession, what we are saying now is at 5% level, we can say that with confidence, if you look at the confidence interval, with confidence that with 95% accuracy, let me put it this way, 95% accuracy to say that ball possession impacts positively on results. And for each unit increase in ball possession, it will lead to 0.5, that's 50% increase in the chance of having a good result. That is that's each unit rise, each unit increase in ball possession increases your chance of getting good results with the coefficient of 0.5. Do that make sense? Does it make sense?
Sorry, explain the 0.020 on that p-value.
That's the p-value.
Yeah, explain
the p-value. Okay. So the p-value is just we are running statistics. It is not at that we can't say for certainty, but we can place it on probability on a probability scale. That's at 95% confident level. I'm sure that ball possession, what is it? I'm sure that ball possession. I'm sure that
is 0.020.
Yes, it's less than.
So how is 5% and 95% coming up?
Very good. Sorry, 0.5. I mean 0.020.
Good.
Is less than 0.05. True or false? I say 0.020 is what? Less than
0.05.
0.05.
That's correct.
That's correct.
So what I'm saying, since it's within this bandwidth of it's 0.05, that's the 5%. That's 5%. Since it's less than that, it has to be less than or equal to 5.
Okay. Okay.
It has to be less than or equal to 5. So at 95% confidence level, I can say that ball possession has explanatory power, has a predictive power on the outcome of a result. And for every unit increase in ball possession, it has, it's 0.5 impact, positive and significant impact on results. Is that okay? It has positive and significant. What makes it significant is the p-value, which is less than 5%. It's possible if p-value is around the is 0.08. What we'll simply say is that though there is a positive impact of ball possession on results, it is not significant at 5%. It's not significant because 0.08 is greater than 0.05. You understand? So, and once it's not significant at 5% level, which is the threshold that we use for social sciences. In pure sciences, they stick to 1%, that is 0.01. So before you can come out to come and administer a vaccine, your statistical analysis will be tested at what's it called? 99% confidence interval, not 95. Meaning that your p-value must either be less than or equals to 1 for pure sciences like medical. But for social sciences, the degree of freedom kind of error that is allowed is at that 5%. So if as our p-value is less than 0.05, it means this result is significant. This result is significant. It's not only significant, it's positive. The coefficient of a ball possession is what will tell us whether it is positive or negative. So the coefficient for ball possession is positive, am I right? Is 0.5. The p-value tells us about the significant level. Is it less than or equals to 0.05? Now it is less than the 0.05, so that means it is significant. So if we now go to the coefficient, is it positive or negative? Now that it's positive, so we can now say that ball possession has a positive and significant impact or effect on what's it called? The outcome of a football match results. That's the interpretation.
Excuse me, Doc.
Yes, sir.
Yeah, thank you very much, sir. On this here p-value, will it be right to say that in this illustration, the ball possession is 98%? You have 98% probability of its a significant contribution.
Take that again.
In this illustration here, since the p-value for ball possession is 0.02,
yes,
will it be right to say that it has about 98% significance?
No. You can only say that at 95% confident level, that is your level of, your chances, or let me say, you are placing a bet that at 95%, let me say, ball possession has a strong influence, very strong influence on your outcome. I can say this at 95% confidence level.
Yes. But
that's the level of my confidence.
Confidence.
That is how sure I am.
Is that 95%? Is that 95%?
It's at 95%.
But in actual, the 0.02 speaks of 98%.
Absolutely. Absolutely. But we are working within the band.
Okay, the interval. The interval.
Exactly.
All right. Thank you very much, Doc.
Thank you, sir. Oh. Okay. Now we have interpreted that. We can also interpret that. The same interpretation. Okay, we have interpreted a ghost attempt before now.
Excuse me, Doc.
Yes, Rama.
Please, can you explain the p-value for the goal attempts?
Goal attempts. Okay, fine. Exactly. That's a good one. Now, the coefficient is minus 0.166, but the p-value is not significant. Though goals attempts has a negative but insignificant relationship with result. That's the interpretation. Goals attempt has a negative and insignificant relationship with goals and with results. That is, yes, the coefficient is negative, but it's not something of worry because it does not fall within our confidence level. It does not have strong evidence for us to rely on. That means I cannot place a bet on goals attempts. But if you go to ball possession, from this result, I can actually place a bet on ball possession that at 90% confidence level, the more we have possession, the more likely we are going to win the match. You understand? But in all, this our model is only explaining 50% of factor that affect outcome of a football match. That is what our R-square measures. So there are obviously there are other variables that impact on outcome of a football match. I think that explains it. We have gone past our time. Any other question? Any other question?
This has been wonderful, Doc. You really did justice to these naughty areas of the regression. Thank you very much, sir.
Thank you, sir. So is it, Amy, do we have the pleasure of continuing tomorrow? I'm just thinking we have overstretched our time now. There are still...
That's correct.
That will be fine.
Okay.
That will be fine if we can continue tomorrow.
We'll start at the same time.
Beautiful.
Yeah.
The same time, because there's something I want us to note. I deliberately did this.
Yes, Doc.
What we use is linear regression. That's a multiple linear regression. Once you're having more than one variable, it becomes multiple linear regression. But what this determines the statistical tool you will use is your dependent variable. what is the nature of your dependent variable? In a football match, what are the likely results you will get? A win,
draw,
defeat,
or
lose. So if you win, 3 points. If you draw, 1, and if you
lose,
zero. So is this model the most appropriate model for us to have used to analyze results and football match results? Will binary regression, will it have been better?
Are you asking a question?
I'm asking a question, but I'm not expecting an answer.
Okay.
Until tomorrow.
I just want us to have a thought over it. Maybe when we meet tomorrow. And from the slide from the question I shared, if you have a starter on your system, let's try and run, even if it's to run this one that we have done. Run it so that if you have issues, you can call me tomorrow. You can call me tomorrow. In fact, where I am, you can see that there's no noise. Nobody, no Wi-Fi calling, or apart from phone calls,
distraction.
Because I'm actually out of my base. So anytime tomorrow you can call me. I'll be available to pick the call anytime from 9 in the morning. It's fine.
Okay.
Yes.
Okay. Thank you very much,
Mr. Simon.
Thank you so much.
Friday. Yeah.
Hello, Mr. Simon.
Yeah, Pastor Friday.
Thank you very much for taking your time off to teach us. But I will be calling you so that I'll become like you. You must reproduce yourself in me.
I'm honored, sir. Thank you very much, sir.
Thank you so much.
Thank you.
Please, Dr. Simon.
Yes, Dr. Chika, how with you?
Yeah, please, we'll appreciate if you could share the recorded version.
Okay.
Of platform. Yes,
okay.
Please. All right.
No problem.
Thank you for your time, for everything. We appreciate.
Thank you. Yeah. Thank you for the opportunity.
We are most grateful, sir.
Thank you, sir.
Thank you for attending.
Governor,
thank you for honoring the invitation.
Thank you, Governor, for making it happen.
Dr. Simon. Enjoy yourself.
Thank you.
Governor,
No
thank
distraction. No attraction, no distraction.
No distraction. Yeah.
Pastor, good evening, sir.